2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey everybody, welcome out there. Another specialized segments today. You know what that means? We can have fun. Exactly, I get to have fun. It's a tutorial type deal, and I'm Ernie Roberts, by the way, and I am your host for Mathline. Mathline, we take a few days occasionally to do just developing a topic and working it really, really hard, getting a lot of practice, a lot of exercises, and we ask you to take a pencil, paper, work along with us, and we'll work some problems together here, live on the air. Not quite live, though, this time, but as you can sit back and relax at your own house, your own room, wherever you are, and let's do some math. And let's see, speaking of which, what's going on today? What are we going to be working here in our little Mathline world? Stuck with a midpoint. I like that. Stuck with a, oh my goodness. That must mean we're going to be looking at midpoints today of line segments. And that, by the way, folks, there's not a midpoint of a line, not a midpoint of an array, but it is a midpoint of a line segment. Little geometry coming our way, but you know me, even with the geometry and the measurements and stuff, I'd like to stick some algebra in there also. So we're going to see a little bit of all this stuff going on. Hey, you're not stuck with me, you're stuck with a midpoint, maybe. I think we're going to have a good time today. So sit back, let's do some math. Let's see where we're starting. We're actually going to do some math. Some people say, well, usually you can start sometimes this theoretical stuff and all that. We're going to actually look at some numbers and put them on top of this thing. Oh my goodness, how about that? Let's do it. Let's go for it. Right here, it says M is the midpoint of HK. Again, notice I've got the line segment over there. There are not arrows on that end, okay? It looks like it's getting a little darker on the edge. I just made it darker, I guess. But that just tells us that's a line segment. And by the way, you have to have a definite end, two end points in order to find the midpoint. Does that make sense? Of course it does. It should. So let's look at this thing here. What is this thing, this HM? This HM equals 7.6 or 7 6/10. Whew, what does that do for us? Well, it basically tells me that's the measurement from here to here. It is, and if these were centimeters or inches, we're just going to use units today, all right? We're not going to worry much about what kind of inches, centimeters, meters, all those good things, miles. We can put all sorts of different units there. But let's go with that. And what we're wanting to know is, what is the length from H to K? That's what that means, by the way. HM says, let's find out how long it is from H to M. What's the length? What's the distance between those 2 points? Well, 7.6, there we are, 7 6/10. Guess what? The same story is going to hold true from M to K. Now you say, Ernie, how'd you know that? There was a key word. Oh, words are so important, aren't they? We're talking about midpoint, so we're stuck with a midpoint here also. And that's where we start. So how about it? 7.6 or 7 6/10, right there we go. And we want to know what's the entire piece of line segment there from H all the way to K. So let's go back just a second. We've got from H to M, we were given 7 6/10. We also went ahead and figured out that from M to K, it's 7 6/10 because of the midpoint. Now we're going to do this, we're going to make it kind of a little expansive here because we're working with decimals. Everybody loves decimals, right? We're going to stick a fraction on here in a minute. Then we're going to start putting some X's and algebra symbols. And I just want you to feel like, hey, we can handle it no matter what he puts on those line segments because we can understand the principle. So if we add these together, we will get MK, which we have decided. Did I say MK? How about HK? We already know what MK is. There's 7.6. Let's look for HK. We'll double that. Or we'll add it together. It's the same effect, isn't it? Multiplying by 2 or adding a number times plus itself. Well, let's see where we go. I like the fact that we're going to have 15 2/10, be it inches, centimeters, what have you. Again, we could multiply the 2 times this, or we can add them together. And there's our story. So starting off right off the bat, think about it. Think about it. We're going to be multiplying by 2, or perhaps going in reverse, we'll divide by 2. So, got it easy? I think so. So let's take a look at our next couple of problems that we've got going here. I said fractions. You know me, I love fractions. So let's take a look at this fraction problem. It says J is the midpoint of MN. And there's J hanging out right there in the middle of segment MN. Notice, once again, we got those little bars over there. no arrows. It's not a line. It's not a ray. It's a line segment. So we're going to call it segment MN. We have JM this time giving us 6 3/4. You did it. Mixed numbers, Ernie Roberts. They love you. Well, if J is the midpoint, that means that going from J to N, we're also going to have the same length as we had from J to M. So here we go, 6 3/4. I'm interested in what's going on all the way across. So basically, if I add these two together, or how about it? Let's multiply by 2. Let's do both. You said both? Yeah, I want to show you. Get the same answer, right? No matter which way we go, we're going to get the same answer. So let's put it 6 3/4. We'll add 6 3/4. I just love fractions. We all love fractions, don't we? Everybody's out there going like, what drug is he on today? 6 and 6 will give us 12. And we've already got fourths, so we don't have to worry about common denominators on this. That's a nice luxury. And it looks like we've got about it, 6/4. Let's clean that one up for sure. That's going to give us, looks like 13 1/2. Your lucky day, right? 13 1/2. Now, question is, could I have done it with multiplying 2 times, what was it, 6 3/4? Let's do it. 2 times 6 3/4. We all know the game plan. Everybody know the game plan? Out there. We need to make this become, yes, got to make it improper. And we need to put a 1 under that too. So let's go for it all in one fell swoop here. 2 over 1. And this one we're going to say 6 times our 4. Remember that, my friends? That's how we make improper fractions. 6 times 4 gives us 24. Tack on the 3. And we're going to multiply 27 over 4, it looks like. How about that? Yes, everybody's saying, Ernie, cancel, make this easier. Let's do it. Divide 2 into both of those. It goes 1 time. There goes a 2. And goodness sakes alive, look what we have. We have 27 over 2. That's not 27 1/2, is it? No. Actually goes into 13 times with 1 left over. It also gives us 13 1/2. So with the picture, look at it either way. Basically, you can say we're adding the same lengths together to get that whole full piece, which, by the way, we decided is 13 1/2. Or we could just skip the adding together and just double it. Multiply by 2, just like we did on the last problem there when we worked with the 7 6/10. We ended up basically multiplying by 2, and we had, 15 2/10 out of that when we doubled it, or we add them together. So you got it? You see what's going on? That's our game plan today. So we're going to work with midpoints. We're going to be on midpoint today. And so we're going to do a little arithmetic, but we're going to also start mixing some algebra in there. So y'all are waiting for that. Just be patient. We'll get there. Let's see what our next problem is going to deal for us here. It says J is the midpoint again. That sounds familiar. We've had that kind of going along, but that gets you in the routine. Now I'm going to tell you something. A lot of times you're going to see M popping up as midpoints, but read what they tell you. Read what they tell you. And here we're saying that we've got J being the midpoint. So just draw your picture. Let it happen. There we have J in between M and N. And by the way, these two little pieces are what we call congruent. I'm going to go ahead and bring a few more terms in as we go along here. That means their lengths are the same. Now, this time I pulled a switch on everybody. Everybody notice? This time I decided we're going to let the big segment have the measure of 6 3/4. So that means we need to divide this into 2 equal pieces, 2 parts. So whatever Jn over here is, by the way, that's also going to be Mj. It's going to work out. So some of you are going like, I bet you could take 6 3/4 and you could divide it by 2. I think that's a great idea. And someone else is out there thinking, but you know what? I see it differently. I think we could say, take that 6 3/4 and multiply it by 1/2. Take 1/2 of the whole length. And I'm going to tell you something. They mean the same thing, do they not? They get you to the exact same place. Just make sure that you don't decide to keep the same sign. Because if you were doing dividing on both of those, you would not get the same answer, nor if you were putting multiplication on both of these, you would not get the same answer. So one's division, one is multiplication. So to divide by 2, works great. To multiply by 1/2, does the same thing just as effectively. In fact, this might happen quicker than that one because we've got to do improper fractions, don't we? So we've already played this game once with this little old 6 3/4. Let's do it again. It's still going to give us 6 times 4, 24. Add 3, how about it, 27 over 4. We're going to divide that whole craziness by 2. And last time I remember, and last time all of you remember who've done fractions, and most all of us have that are watching the show today, I'm sure, we've got to change that division into what? Multiplication, exactly. And when we do that, we don't just write times 2 over 1, we put the reciprocal. That big R word, reciprocal, 1/2 gets multiplied in there. And I'm looking at 27 over 8. I see nothing's going to cancel. Now the same question comes up over here. Well, and that's the same thing. Well, goodness sakes, it does look like it. Let's see if it does. We've got 27 over 4 again. My goodness, it didn't change, did it? So 27 over 4, and now we're coming right back and multiplying it by 1/2. So it's your choice. Whichever way you like to set up the problem, you're going to get the same value. We do have 27 divided by 8. Oh, let's go ahead. Let's go for mixed numbers. That's what we're here on Mathline for, right? All right, I'm going to tell you right now. It goes in there 3 times, which makes sense. Doesn't always happen this way, but it certainly makes sense on this one because that's what half of 6 is. Now, let's talk about half of 3/4 since that's looking like it's going to work pretty well. And I believe, what are we going to have? We're going to have 3/8 left over maybe? Let's check it out. Goes in there, what? 3 times? 3 times 8? 24? Then subtract. Okay, some of you say, would you put that on paper? I'll be glad to. 8 divided into 27. That's what we're doing, right? That's what fractions mean. They're division. And we're going to make it a mixed number. How about it? Let's see. It goes 3 times, as I said. 3 times 8. Click along. That's 24. I have 3 left over. You have 3 left over. We put an 8 with that. And you know what? That tells me that we have 3 3/8 for JM, in case someone wanted to know about JM. But since we're asking for JN, I'll give it 3 3/8 also. Put them together, you get back to 6 3/4. So don't let the fractions bother you. You've got the techniques, you've got the skills to deal with them. No matter what kind of craziness I give you today, right? We can maneuver these midpoints. We aren't stuck with them. We're going to love them, right? Okay, don't get too excited, Roberts. I know. Let's take a look at the next one. I told you it's going to get a little crazy on you. So let's see what happens. Do y'all see what I see? I see a variable. I see n. Well, we've got x, we got m, and now we've got this crazy n. N is just some number. It's some number that's going to make these lengths positive, all right? I didn't specify, but I did ask a question. I always do that, don't I? Let's put on the picture here, let's put what we've got. We've got 2n minus 5. That's what that means right there. From x to m, you got it, 2x minus 5. Now, the midpoint tells me, that these two little guys are all the same length. So in other words, it's the same story going from x to m as it is going from m to y. xm and my, oh my, yeah. Now, what are we going to do to get to the xy? And some of you go like, oh, Ernie, we don't like those algebra things. Oh, they're simple. They're not a problem. Don't get nervous about them. First of all, remember I said we could repeat ourselves right there and say, oh, we have 2 n's here and 2 n's there. Well, how about it? Let's add them together. 2n minus 5 plus 2n minus 5. Life is good. I see 2 and 2 gives me 4. It still does, by the way, my friends. Some people say, that new math? Oh, new math still gives you the facts, all right? And you got a negative 5 hooking up with another negative 5. We're adding those together. It's going to give us minus 10. That's one way to look at it. Remember I said we could take the individual pieces. They're the same. Add them together. Life is good. The other side of the picture, what if we multiplied? What if we doubled it? Because that's what midpoints are doing. They're allowing us to take half, or in this case, since we're getting bigger, we're going to double. So how about it? 2 times 2n minus 5, little algebra, actually a little pre-algebra here maybe, little distributive property. I'm going to call it what it is. That is the distributive property. By the way, over here that was like terms. Those of you like to keep up with the algebra lingo and jingo. There you have it. Now let's multiply 2 through here. We're going to double it. That means we got 4 n's. That means all of a sudden we are not 5 in the hole, we're now 10 in the hole, or we have a minus 10. And there's your, well, it's the same thing, isn't it? There you go. So again, adding the pieces together works great to get to the long piece when it's a midpoint. That's the only time, all right? Actually, that works anytime. When we have a midpoint, though, we can repeat ourselves. Otherwise, we may have two different ideas here. Hey, guess what? I think that could be a good problem coming up here in just a minute. So just hang on. We'll see where it goes. By the way, you say, well, Ernie, what about n? What's it equal to? As long as we don't get a negative number, n can be anything you want it to be. And when I say a negative number, and actually we don't want a 0 because these are lengths of segments. So if I were to figure out where it would equal 0, I believe 2.5 is going to be our culprit here. If we put a 2.5 in there, this disappears, it goes to 0. If we put 2.5 here, it goes obviously to 0. If we go bigger than 2.5, we're going to get negatives, and that does make no sense, all right? So is that right? Yeah. If we go bigger, no, if we go bigger than 2.5, excuse me, if we go bigger than 2.5, we're going to be good, all right? It's the numbers that are less than. It's when we start putting in numbers like 2. See, 2 times 2 is 4, minus 5 gives you -1. Can't have negative lengths, all right? So that's where we got to watch out. So basically, as long as n is greater than 2.5, how are you on 2.5 or with a fraction, as long as we have that, we're good. These expressions will hold true. You can't have negative lengths overall. And you can't have zeros because then you don't have segments anymore. Easy to remember? Very easy to remember. So let's take a look at another problem coming along here. See what we got. And by the way, just a reminder, this show can be seen in its entirety on YouTube on down the road there. And let's see how we get to that fact. By the way, guys, do we have it there? There we go, YouTube. Like and subscribe to Mathline Online. And of course, we always advertise about what we're doing specialized segments on Facebook. We want you to love us, like us there, and also send us some questions there. We enjoy hearing from a lot of our Facebook viewers, and some of you are a little shy about calling in during those live call-ins. We still want you to call in during live call-in, but this is another way you can do it. Like us, follow us there at www.facebook.com, Mathline Online with a / between us. Now, got another one here. You say, oh man, you had those variables, that 2n minus 5. Take a look at what I got now. Ooh, I got 4 times the square root of 3. And that's the length of mj, or jm, right here. So j is our midpoint once again. Kind of keeping that theme, haven't we? Oh, actually, we did an m earlier. Never mind. Let's keep looking here. We've got 4 times the square root of 3. Right there it goes. And again, the same effect. We want to know what is the whole length of mn. You Algebra 1 teachers, you pre-algebra teachers are going like, oh, he's going to review us. He's going to make us review a little bit about, yes, about radicals. So if we got 4 times the square root of 3, which, by the way, that's an irrational number, but it's still real. You can put it in the calculator, you can get pretty close. It rambles on and on. But what's going to happen? If I add 4 and 4 together, I get, you got it, 8. And the square root of 3 simply goes along for the ride. So that was really painless, wasn't it? Looked kind of nasty, but you got a picture. Put the numbers on it, work with it, okay? Throw the pen around, whatever. Now, how about the multiply by 2 business? You remember I mentioned something about doubling because we're going from small pieces of 4 square roots of 3, and we're going to double to get to here. Well, let's do it. And, you know, 2 times 4 does give us 8. Don't do it. 2 times 3 here. We're done. Bring the square root of 3 along for the ride, and there you go. See, over here, when we add like terms, it's like adding 4x, and 4x you get 8x. This time the x just happened to be the square root of 3. Same thing here. It's like saying 2 times 4x, you get 8x. In this case, the x is, again, square root of 3. So a little algebra. Like algebra, we call them like radicals, similar radicals. They are just like terms or similar terms. Just let the x and the root of 3 become 1. All right, that gets us going here. Let's do some algebra. How about it? Let's take some algebra here. Let's see what we got. It says j is the midpoint of mn. Here we got jm equaling 5x minus 6. nj equals 2x plus 9. And we are definite for sure we have a midpoint. J is the midpoint. And we've got an M and an N out here that are the same distance from J. One's going to the right, one's going to the left. That's the midpoint magic. Now, what do we know? We know this. we know JM, by the way, without that bar, that means the length, all right? So the length of JM, in case you were wondering over and over here, it's now a great time for me to finally explain it, I know. But that's our length. So let's put a 5x minus 6 there. And according to this, from J to N, or N to J, however you want to look at it, it's going to be this value of 2x plus 9. Now, notice what we want to do. We want to figure out what is Jm, what is Nj, what is Mn, and I don't want it just in terms of x. I already know what it is in terms of x. I just have to add these two together, and I'd say I've got the whole Mn. What we want to do is actually get a value, a number that works here. So by definition, midpoint divides these things into, yes, congruent segments, which means they have the same length, which means when it's time to set things equal, oh, did I say set things equal? We're going to set things equal. How about it? 5x minus 6 collides over there with 2x plus 9. Oh, it doesn't collide. They actually meet at J. And they're going to be a happy meeting because they're going to be the same length. Oh, you know what? If we know those two lengths, we can figure out what Mn is. I like that. I like that. It's going to be easy to do. In fact, some of you say, you know, Ernie, if we just know one of those lengths, we could find Mn. You all are watching Mathline and doing a great job with it. Thank you. Now, let's play this thing out, see what's going to happen. It's easy. It's algebra, simple algebra. Remember what we want to do. We want to get our x's together, and we want to get our numbers, our integer values over here together. So let's start first with subtracting 2x. Now, why did I subtract 2x? Because I've got a positive 2x. I'd like to move it over to the, you know, that other side, left side. Did I just point that? I never know how it looks on TV. So we put a subtract to it. So we got to do it on both sides, all right? So we're going to do it to left and the right, and we're going to subtract that 2x and see where it takes us. Well, it says goodbye to the 2 x's. That was the whole point of doing that. So big X going there, but it's gone. Now we have a 9 left over on the right. And the left-hand side, things did change a little bit. And notice I like to line up the x's. I like to line up our numbers because you really see where it's going on. So this is going to give me 3x because it's easy to say 5x minus 2x. That means I still have 3 of them left. 3 x's, not just 3, but 3 x's. And bring the 6 down for good measure because we like it. We can't get rid of it yet, but we're going to do that. Let's see, it says minus. So what I need to do is add 6 because I'm wanting to get rid of it. And if I do it to the left-hand side, I've got to do it to that other side, that right-hand side. I'm afraid to see where I'm pointing to on the TV screen. It's always funny. Let's see. The 6's go away. I'm left with 3x, and I am going to equal out to 15. And you know what? All of a sudden, this is looking so easy, isn't it? Because I'm saying 3 times, that means 3x. 3 times something gives me 15. Just simply divide both sides by 3. That'll get you where you're going. Or you could just think your times tables through there. You got that easy. 3 times what? 5. Yes. So x equals 5. You say, Ernie, are we done? Almost. Almost. What's the point of the problem here? Oh, we got to go back to Jm, Nj, and don't leave out Mn. So let's start first with Jm, which equal to 5x minus 6. Question mark for all of you out there. Yes, yes, yes. It's just substitution, isn't it? Because we now know what x is equal to. We have been enlightened. We know x is 5. So here we go. 5 times 5. And take away that 6. Oh, everybody knows 5 times 5. Well, in case you don't, 5 squared, 5 times 5, gives you 25. And if you take 25 minus 6, you're going to have 19. Now, I trust our work, but I still want to make sure. So let's go for Nj, because we know it should be 19, right? That's what we're looking for. Everybody got it? So let's see if it worked. So Jn or Nj, either way. We've got 2x plus 9. Put your 5 in there. Oh my goodness, I like the look of this one. Looks like 10 plus 9. 19 again. So we've got 19. 19. Oh, we'll put them right down here in the picture so everybody can be happy. There you go, a lot of 19s. Whew, there are 2 of them there, 2 of them here. There's all the same 19s. But what about the MN? Well, MN is going to be, let's put it right up here since I've got a little bit of room left. It's going to be 19 plus 19, which is good news, to get us to 38. And since these are the same, that's important. We want them to equal each other. So that means 5 is good. It leads us to the 2 19s, which lead us to 38. And you know what? I think our problem is solved. We've got all the 3 pieces we wanted. And hopefully you aren't stuck with a midpoint. I hope you can go like, hey, that's not so bad. We're going to look at them some more next time, all right, with another segment here of specialized segments. But in the meantime, remember, we do have that live call-in from Monday through Thursday, and you want to be part of that on your local PBS stations, all right? And for tuning in today, I hope you had a good time, and we will see you again next time.